So I've gotten a request to do the problems in the back end of the packet. So some framework on these questions in the back of the packet. I like these questions, and you're going to see questions like this in the next packet, but they don't really show up on the exam, mostly because they're very open-ended questions. They are definitely assessing things, but much more in an indirect way. So let's go through those questions first, since I got that in an email, and then Lauren will go through your questions as well. So the questions are, I'll show you the first one. A technician working in your laboratory wants to modify a procedure for delivering calcium to a setup that circulates gallons of high concentration calcium solutions through multiple alga ponds. The current lab uses high purity CaCl2 as the calcium source, but it costs more than calcium carbonate for the same purity grade. The technician assures you that he has done the analysis and knows that there would be a definite cost benefit close to $250 a month for the amount of calcium used. Would it be advisable to make the switch? Would you recommend he move forward with showing his proposal to your common supervisor? What other information may be needed? So you actually have the ability to answer this question already. And the reason I put these questions in these packets is that, one, it's designed to pull you out of context. A lot of students try to focus on the materials if it's only relevant to the course, and actually it's very relevant to any chemistry career you're going to go into. Now, the other thing is to kind of get you prepared for the real world, because even in department meetings, we get bad ideas. People make proposals, and they make proposals that, if you sit down with pencil and paper, don't actually make sense. And this goes two ways. You don't want to be the person that proposes an idea that with pencil and paper isn't going to work, and you do it anyway and it doesn't work. And you would also like to be the person that sits back and saves your company or your business or your organization a whole bunch of time and money by saying, well, hey, they're saying we should be doing this, and here are the issues. So in terms of how I would approach this question, and you're going to find that there's no answers to these on the course website because these are meant to be open-ended discussion questions. I don't really want to drive you in a direction. But when I present this in class, I ask students, what do you notice, what do you know about calcium carbonate? And students start mulling around, and eventually someone's going to point out and say, well, calcium carbonate isn't soluble in water. It has an insolubility rule associated with it. So calcium carbonate should actually be insoluble in water. It's like, yes. And so if you look at the problem, it says high concentrations of calcium solutions. That's why they were working with calcium chloride. Calcium chloride is super soluble in water, whereas calcium carbonate is not. So if your technician switches to calcium carbonate, while calcium carbonate will dissolve to an extent, it will not dissolve to high concentrations as are alluded to in the problem statement. So what your technician is proposing, while yes, if you did buy calcium carbonate, it would cost less, it's ultimately not going to work. What he is proposing is basically using something that's not soluble in water. So this problem is, what he's proposing is doomed to failure. Now the second question. Next to the same setup as the calcium-rich pools are the control ponds containing algae that are deprived of calcium. While you work with deionized water, good laboratory practice, GLPs require you to work with a filtration system that leaches calcium into the system via gypsum, calcium sulfate, used in the manufacture of the filters. Because the manufacturer will avoid any guarantees about filtration quality if you attempt to modify the filters, your supervisor would like you to come up with some options that would remove the calcium in situ that she could pass on to the lead scientist to determine their viability. What could you do to reduce or capture the leach calcium? And there's actually two answers to this question. And it's going to boil back to solubility. Calcium sulfate isn't soluble in water, but there is definitely some solubility associated with this molecule. So there's two ways we could look at it. So if we just write out the reaction. So just by the reaction alone, you can look at this and say this is a Le Chatelier's problem. So if we want to remove the calcium that's being leached out, we can add sodium sulfate. And adding the sulfate will drive the reaction to the left side because you're adding sulfate, and this creates, by Le Chatelier's, when you add products, it drives it towards reactants. So you'll remove it. Another option, and this one's a bit more subtle, sulfate warns bisulfate on reaction with water. It is a weak base. So if we added something like sodium hydroxide, NaOH, NaOH is going to drive this reaction backwards, which will produce more sulfate, which will drive this reaction backwards. And this is a demonstration of the common ion effect. So this is one way you could easily do it. You could add sodium sulfate, which would decrease the solubility, or you could use alkaline conditions in order to drive it back through the common ion effect. A third option is look at the KSP of other calcium complexes. So calcium phosphate, I'll write it up, Ca3PO4, take it twice, is less soluble in water than calcium sulfate. So if you were to add something like sodium phosphate to this solution, what it would do was remove calcium by crashing it out as calcium phosphate. So in this case, you're going to remove the calcium by creating a less soluble calcium complex. So these are three possible solutions you can use, and which one you use depends on the any stipulations you have in terms of the system. So whether or not you can run with alkaline, whether or not sulfates are important, or whether or not phosphates are important. Now the third question, another experiment will look at the effects of ammonia on the productivity of the algae microbes in basic conditions. It is already understood how basicity affects solutions, so now ammonia needs to be delivered controllably to the system. The solution needs to be close to 0.2 molar NH3. What concentration of NH4Cl needs to be added to get a pH of 9.25 if the pKb of ammonia is 4.75? Again, this is a problem you actually already know how to solve. So you've got ammonia, NH3, with water to be NH4 plus and hydroxide. And you know you want the ammonia concentration to be close to 0.200 molar NH3. You've got a pKb 4.75, and you want a pH of 9.25. So this is just a basic buffer problem. This is one of the pH from pKb problems that you've solved. And to solve it, we're just going to build an ice table. So we know we've got 0.2 molar NH3. We're going to assume all the hydroxide comes from the ammonia. So we get minus X plus X plus X. So 0.2 plus X. Hydroxide is plus X. Oops. Minus X. Come flipped. And you're being asked for the concentration of ammonium chloride. So this is the number you need. So let's just put a dummy variable in there. I don't know, B. So we get B plus X. We have Q equals the concentration of NH4 plus, concentration of hydroxide, all over the concentration of ammonia. And we know the pH is 9.25, which means our pOH is 4.75. And so from that, we can get the concentration of the OH minus, and from there you just kind of plug everything in. We've got Kb from the pKb. We know the hydroxide is X, which is also 10 to the minus pOH. The ammonia is 0.2 minus X. And the NH4 is whatever the concentration is plus X. So now it's just a matter of rearranging and solving. So that's how you answer the questions in the back end of the packets. So now the chat questions. Can you give a review number 4 and number 12 in the WebAssign Buffer Bootcamp? So let me bring that up. And I think these problems are randomly generated, so my question may not be exactly the same as yours, but it should be the same type of question. Yep, definitely randomly generated. So y'all can see at home. The question is, for the reaction below, Kc is 1.22 to the negative 2. And the reaction here is 2ICl gas goes back and forth to I2 gas and Cl2 gas. And it wants to know the concentration of I2. The initial concentration of ICl is 0.389 molar. The red number there on my screen indicates that this is a randomly generated number. Ultimately, our answer is going to be 0.0352, but we'll work to how you get to that answer. So any equilibrium problem is going to require an IC table. We've got ICl, I2, and Cl2. The initial concentration is given to you, 0.0352. We're going to, since we're not given any other concentrations, we're going to start with IL2 and Cl2 as being 0 concentration. The change in the reaction is reaction coefficient times extent of reaction, so minus 2x, x, and x. In value, 0.0352 minus 2x, x, and x. And we're being asked to find the equilibrium concentration of I2, so we're basically looking for the extent of reaction. We also need our KQ equals Q, so Kc, our equilibrium constant, equals concentration of Cl2, concentration of I2, all over the concentration of ICl squared. If we plug in the first E row, we get x times x, all over 0.0352 minus x squared. Now, there is a little trick to this, but you don't need to use the trick. You can actually just go out and solve the full quadratic. But if you work it out, Kc equals x squared all over 0.0352 minus x squared. We can factor out the squared, so it's x over 0.0352 minus x squared. So the square root of Kc equals x over 0.0352 minus x. If we rearrange, okay, we're going to x1 plus the square root of Kc, square root of Kc times 0.0352. So x equals 0.0352 times the square root of Kc over 1 plus the square root of Kc. Now, here's hoping this actually works out. So Kc in this case is 1.22 e to the negative 2. And I'm going to make this easy. Square root of Kc is just the square root of that number. Now the way I had it written on the board, the x here, x equals the square root of Kc times the starting concentration, 0.0352, divided by 1 plus square root Kc. So I'm just going to put that into my formula. Square root of Kc times 0.0352 divided by 1 plus the square root of Kc. Stop doing that. And I get 0.003501. Looks like it's carrying more decimal points. So the answer it gave was 0.0352. I'm guessing I wrote down the K value wrong. Oh, 0.389 for the concentration. Haha, my mistake. So yeah, if you do the 0.389 like you're supposed to do, you'll get the answer that's actually in the key. So that's how you do that one. Again, you're just going to set up the IC table and work it out. The other question, 12a. Write the balanced chemical reaction describing the reaction of excess sodium hydroxide with the following acids. So, this case it gave me H2SO4. I'm guessing in all examples. I guess I can refresh it and see. I'm going to guess that it's a diprotic acid. Yep, diprotic acids. So, when we write acids, we try, generally speaking, try to leave the acidic hydrogens at the front. So in the case of HCl, that first hydrogen is acidic. In terms of acetic acid, HC2H3O2, the first hydrogen is acidic. For sulfuric acid, H2SO4, the first hydrogen is acidic, and so forth. So anything, the first hydrogens are generally considered the acidic ones, and this is how we quickly identify something's monoprotic, diprotic, triprotic, etc. So if you're running with excess, it means that you're reacting away all the protons. So since you've got two hydrogens, you're going to need two equivalents of your base, which are going to create two equivalents of water, and then every hydrogen is going to be substituted out by the spectator ion in the base. So this would give you Na2SO4. But again, like it's any acid-base reaction. Like the whole reason they're giving you the excess is to say that you're completely reacting away the hydrogen. So if we had something like phosphorus acid, H2PO3. Now, the other one, approach the easy pH discussion problems on the discussion board. So this is the discussion board, the simple pH problem from the discussion board. We have acetic acid going back and forth. And let me write this up on the board. You're not given pKa, that's just a mistake, so you're going to need to Google it. The Ka for this one I think is 1.8, 10 to the negative 5. But you're given that the concentration is 0.1 molar acetic acid and 0.01 molar sodium acetate. There is a reason for those numbers. Some online helps are going to tell you to use the Henderson-Hasselbalch equation. If the concentration is less than 0.1, the Henderson-Hasselbalch approximation typically doesn't do that well. But if you're here, you're being asked to find the pH and the pOH. So the way we're going to do this, you may have guessed, we're going to set our equilibrium constant equal to KQ. We're going to set our equilibrium constant equal to Q, which is H plus, times C2, H3, O2 minus 1, all over the concentration of H, C2, H3, O2. Build our IC table. So ICEE. We've got the acetic acid, H2C3O2, H plus, and then the acetate, C2H3O2 minus 1. We're given initial concentrations for the acetic acid is 0.1. We don't have any H plus, and we've got 0.01. Changes, minus X, X and X, so we get 0.1 minus X, X and 0.01 plus X. So we're going to plug this into the equation. We get X times 0.01 plus X over 0.1 minus X. And you're going to have to rearrange this to solve for X, the extent of reaction. So X in this case is opposite Ka plus 0.01 plus the square root. There's a whole bunch of stuff in there, all over 2. And again, you're just going to have to rearrange the quadratic equation to get to that point. Once you get x, you're not done. It's asking you for the pH and the pOH. So that's going to be connected to the concentration of H+. If we know the concentration of H+, the pH is just the negative log of the concentration of H+, and the pOH is just 14 minus the pH. You're welcome, Lauren. All right, other questions? Any other questions out there? Is there a way to do the quadratic equation in Excel? Not directly. You generally have to use the solution form. So x equals the opposite of e plus or minus square root of b squared minus 4ac all over 2a. Excel is not a symbolic logic solver. Because of that, you really kind of have to do the legwork ahead of hand. There is another way, which is skull-seek, where you can take your terms, put them in as a function. So you can write out the quadratic equation as a function of the cells and then optimize it so it equals 0. That's a lot of work. But generally speaking, there's no way to directly solve the quadratic equation in Excel. You just kind of have to use the quadratic formula. Polysolve, and polysolve's on the calculator, right? Yeah. We invented technology to make our lives easier, so totally use it. And I understand the necessity of understanding how it solves it, but be honest with yourself. That's why we have calculators, so we don't have to do these things by hand anymore. One of the arguments I'll occasionally have in meetings where they talk about students being digital natives, because I really hate that term, is I actually have a slide rule from the 1970s. It still works. And I asked them, could you use a slide rule? Well, no, I have a calculator. Exactly. you're an analog native, but you don't know how to use a slide rule, so why would like a student know how to use Excel necessarily, right? So oh, hey Elijah, how are you doing? Surprised it's recommending my live streams to anyone. Yeah, we're going to see how Organic 1 goes for you this fall. The labs are not as good as they were for Chem 2. Probably going to be doing a lot of modified versions of the labs as well. I try to, ideally I would test these out before you do them, but don't really have that option right now. And there are some labs in the lab manual that are just atrocious for organic chemistry. Yeah, good to know. Hopefully the pH isn't too hard for you. Their current course right now is covering pH. Yes, so we're going to meet once a week for a lab. You're going to be required to have a mask, wear your goggles. I assume we're doing temperature checks. I may not personally be doing them, but I think you have to do a temperature check at Montague Hall. Or there's some building on campus where you do the temperature check. They're going to give you a card, and that card gives you access to the campus for the day. I have to go get a card each day as well. And you're going to be working on your own. So only 8 students in the lab. Each person gets their own. There's no lab partners. It's just you by yourself. The first couple labs, so we're still developing the schedule. The idea is to have as few labs on campus as possible. We're also worried. That's a good word for it. We're worried we're going to go back to phase one. So the plan right now, and again, this plan is constantly fluctuating because it's not just between faculty, it's also between faculty and administration. The first labs are going to be, the first two labs, which are the check-in labs, are purely going to be online. So we're just going to have a Zoom meeting or a Teams meeting and talk about what's going on. The first 4 labs you actually do are not going to correspond to where we are in the course because these are considered the 4 labs we think are essential to doing well in Organic 2. So the first 4 labs, the first one's going to be pretty reasonable based on the schedule. That's the first draft of the schedule. But you're definitely going to find like second, third, and fourth labs are definitely on topics we have not covered yet. And then every lab after that, they should pair much better with the course material. But again, we're going to make the assumption that we're closing halfway through the semester. So we want to get those 4 labs out of the way like immediately, as soon as possible, to make sure that you get the 4 central labs in. And then every lab we can do after that is going to be considered, I wouldn't say a bonus lab, but it'll be nice if we can do it. Now, what I'm going to advocate, and we'll see, I think I've got my next meeting Wednesday or Thursday about this. Right now I've got 2 Orgo 1, 2 Orgo 2s. The Orgo 2 isn't filling up. I'm going to recommend, hopefully, that we can switch one of those Orgo 2 labs to an Orgo 1 lab and do 3 sections of Orgo 1 on Sally campus, because right now we've only got 16 slots open for our organic students, and my courses are definitely waitlisted. So I think we could easily field a 3rd Orgo 1 lab. On top of that, if we do it right, so like Orgo 1 is Monday, Tuesday, Wednesday, and then Orgo 2 is Thursday, it minimizes the setup. But a lot of this is still in motion. We're trying hard to get this all finalized before August because we do understand for students, like, y'all have lives and y'all need to plan what you're doing this fall. We're trying to be much better than state, and that state has gone back and forth about, oh, it's all seated, oh, it's all online. Why aren't they offered online? The lecture itself was offered online. What we concluded after our experiments with Chemistry 1 and Chemistry 2 is that if you're taking organic, you are going to be in a lab setting. And if you're going to be in a lab setting, you need to do labs. There is no substitute for doing lab experiments. Your Chemistry 2 labs, take-home labs, are not truly chemistry labs. You would never work with an eyedropper in the lab. You would never work with plastic glassware. You would work with titration burettes and things like that. Organic is very much a skill. It's not just the theory anymore, it's also the skill sets. Organic chemists are very gifted craftsmen in terms of making molecules. So a basic take-home, run-of-the-mill organic glassware set is $300. And that doesn't include like heating mantles, it doesn't include the chemicals. There is no way to properly train you in organic chemistry with an online lab. And that was the conclusion we kind of reached as instructors, that if we're going to teach organic, we need to teach it right. We can't just kind of like go, oh, here's kind of an organic kit. And the analogy I've been giving people is it would be like teaching you how to weld using a soldering iron. It's like, oh yeah, this is just like welding. It's not. A soldering iron is nothing like doing welding with like a TIG welder or an arc welder or a plasma torch. They're very different things. Fans of how much of this is being done online. But we also understand that it's not the end of the world if students kind of miss that little bit. For organic, it could be very hard on your career and future courses if you have not physically done the labs. Particularly with organic too, the assumption is that you know how to do melting point, you know how to do separations, you know how to properly operate a rotovap. These are all things you can't really learn watching a YouTube video. So, about PM courses or weekend courses. We traditionally, so the reason we don't do those is more for the faculty. We're only supposed to be working 9 to 5 jobs Monday through Friday, regular semester. And then over the summer, our business days are Monday through Thursdays, 8 to 5. So we do 4 10s in the summer and 5 8s during normal semesters. To ask an instructor to work on the weekend or in the evening is kind of outside of normal business hours, and they can't ask instructors to do that. They had to volunteer for it. So we do have PM courses, but faculty, those aren't considered part of their normal courses. Those would be considered like overtime courses. So it's more how we've laid out how instructors are allowed to teach. And this is why we have the disclosure in the syllabus saying that you need to expect a bigger delay over the weekends, is that instructors are not expected to answer emails on Saturdays and Sundays. They want us to take our time off. They want us to have a good work-life balance. Now, with online courses, I tend to be a bit more flexible in terms of the emails I answer on the weekends, but definitely even for me, the rule is on Saturdays I don't work unless it's something I can respond to quickly with like a one-sentence email on my phone. But that's why we don't do the PM courses or the weekend courses. Now, that's just kind of in general. The reason we don't do it for organic in particular is we don't have the enrollment numbers for it. So last fall, we were not able to get Organic 1 completely enrolled. That isn't true as much anymore. We're starting to see the number of students enrolling for Organic go up. We're not going to talk about the politics of why that's happening, but we don't have the demand yet to justify having all those organic courses. So again, with Chemistry 1 and Chemistry 2, we have some stuff that's offered in the nights. That's more for people who want overtime. Oh, the other reason we don't do the weekend courses is that we would have to pay security to be there. So on the weekend, I think we only have 1 or 2 police officers. During the regular work hours, we have a lot more. So if we were to have weekend courses, we'd also have to pay to put police officers on campus as well. We'd have to pay to have people like clean the buildings on the weekends. So all the other parts of it are just practical cost-cutting measures. Yeah, Elijah, I can't help you much with Bio 2, but I can probably help you a lot with Physics 1. So yeah, feel free to bring those questions to like virtual office hours. Now, Lauren, to finish up on what we were talking about, we were subtly trying to eliminate Friday classes at Wake Tech, and eventually administration caught on to what was going on. So the pushback came, and we had to go back to Friday classes. But we had this great idea, and honestly, it was a great idea, is that we were just going to teach courses Monday through Thursday. And Friday was basically going to be work days for faculty and work days for administrators. And the belief behind this was that as faculty, if you're a faculty member, Friday would be a good day to like grade assignments, grade lab reports, get your side projects going, enter attendance. We would have a lot more flexibility. And the other thing is that because we wouldn't offer classes on Fridays, students could come in at any time. There would be no course conflicts with the office hours. So we could also dump a lot of our office hours like midday to late afternoon on Fridays. And it also meant that the technicians on Friday could clean up the labs, they could set up the Monday labs, and it would be really efficient. But the pushback was that, okay, if you're a clever faculty member, you basically put all your office hours and all your on-campus stuff Monday through Thursday, and Friday you're at home. So you're not really there from like 9 to 5 on Friday because you don't need to be. All right, see you this fall, Elijah. There's some interesting people in the organic course, so I'm looking forward to organic this fall. But yeah, we really wanted, like, that would have been so great if we could have gotten like Fridays with no lectures, because honestly, I think for students, that would be great. It means you only take classes Monday through Thursday. That frees up a lot of your work schedules. For faculty, it's kind of nice that I only had to show up for a few hours on a Friday, so I can do things like grocery shopping and like take care of errands before the weekend. But yeah, we got some bad pushback about that. But about a year ago, if you go look through the old course catalog, you would notice that like Friday courses were like almost non-existent. Like there was maybe one lab offered on a Friday, maybe a course or two, but definitely Friday the campus was a lot more quiet. It was a great time. Particularly, I've taught several Monday, Wednesday, Friday lectures. They're 50 minutes long, and my only complaint about them is that they're so short. Like, it sounds weird to say that, but by the time everyone gets seated, by the time you've done, because what I typically do in the course is we do a warm-up problem. That's about 10 to 15 minutes. Everyone's caught up, or hopefully got their questions answered from the previous lecture. by the time we really get rolling, we've only got 30 minutes to cover any new material. So I felt like I was losing a lot of time just to review, just to getting the course started. Whereas Tuesday, Thursday, Monday, Wednesday courses, like the 75 minutes was actually kind of nice because it was 15 minutes to kind of get things rolling, and then an hour of we work through problems, we discuss things, and we really, that kind of like got you towards the end of what you could really handle. But I felt like we packed in a lot. And I didn't feel like, I would basically start and then immediately have to stop because time was up. Yeah, particularly with higher courses, it's hard to find alternative times. The big reason is the assumption is that you're in college, and so this is just kind of a full-time job. I mean, it's just the hard reality that a majority of people in college are college students, so this is just their full-time job. And there is an accounting to it. Like if we offered organic courses at night, like we'd have to pay for someone to be there. We'd have to pay the little thing with labs is that our technicians only work 8 to 5 Monday through Friday. So if the lab isn't set up properly when you show up for a 6 or 7 o'clock lab, you're kind of on your own, and that can be really detrimental. Because I taught the semester before I got hired full time, I taught a night course, and yeah, we were pretty much on our own. Um, the other thing with night courses, we as faculty have kind of are winning the argument. It used to be a 3-hour lecture on Tuesday and a 3-hour lab on Thursday. And when I taught that course, it was exhausting. We were always out. Class started at 6. We were always out between 8 and 8:30 because I could not handle talking for 3 hours. They could not handle 3 hours material. And an hour into this class, we would just go out in the balcony because I just couldn't, none of us could take that much material. We've talked about splitting it, and we've had some success of saying, okay, lecture is Monday and Tuesday from 6 to 7:30, and then the lab is 3 hours on Thursday. Because labs are inherently 3 hours, so it makes sense that they would just run from 6 to 9. But even as a faculty member, that 9 was really depressing. You get in at 6, the sun was starting to set, and you leave the lab at 9, and it was pitch dark, and you still had 30 minutes to get home. But yeah, for schools, it's just accounting. Night courses make sense when we have high demands, but usually with our major courses, we don't have enough demand to offer even a whole bunch of sections during the week, let alone a night course. Now, hopefully the hybrid will help you. You only physically have to be on campus for that 1 3-hour chunk throughout the week. So if you are going to do organic, try to find a course that does it hybrid and just pick that day of the week. And then the way we structure hybrid is that the lecture itself is completely virtual. It's all online. The lab is the only thing you physically have to show up for, and that's only 3 hours a week, if that. And I think right now we're the only school offering the hybrid. I think state has gone between fully online and fully seated. I don't think they're willing to consider the hybrid option. But this is just my trashing of four-year universities. They kind of don't. Four-year universities aren't structured to teach as well as we are, so we consider the hybrid we use the hybrid during regular semesters anyway. Because we do have students who say, well, I can't do the normal school schedule. Okay, well, here's the hybrid. Hybrid gets you the hands-on lab experience, but you're still taking an online course. Yeah, like we want you to be successful. As faculty member, I want you to be successful. So if times of the day are the problem, you're actually kind of this pandemic has kind of helped you. I mean, it's terrible, but the hybrids are becoming popular because they do kind of strike the compromise of these are the skills you absolutely need to physically be here to learn, and here are the things that you can kind of learn because they're all theory, and you don't need to like sit down, and you don't really need someone to be standing there with you when you learn the theory. Or you kind of do, but you can learn the theory a little bit easier. But yeah, right now that's Wake Tech's plan, is to do the hybrids for organic, because you do need the lab. Like, there are a lot of techniques you cannot just watch a YouTube video and learn. I mean, there's little nuances. How do you grease stopcocks? How do you grease glassware? You can watch a video, but it's very different when you're physically doing it. Like, there's lots of little nuances. Plus, and this is just kind of my view, organic chemistry is the first time you really need to get exposed to super sensory experiments. So one lab I'm working on right now is the synthesis of banana oil. So you're going to synthesize an organic 2, an ester that smells like essence of banana. So you're going to take 2 compounds that don't have any smell, mix them together, and get a strong smell of banana. In my view, that's the first time you're really kind of doing cool chemistry, and so you need to have that sensory experience with doing organic chemistry. It should either be bright colors or very strong smells that you associate with organic chemistry. In organic chemistry, we did like really bright compounds. Like, we met organometallic complexes typically have a lot of color associated with them. So you have that connection now. Not only do you have a sheet of paper that says this is the chemical, you also see the end results. Like, there's some sensory connection to the chemistry that you're doing. And it's something we can't really do at the Gen Chem level, because you're like, the reactions you do at Gen Chem are pretty basic. Organic's the first time you can do things like essential oils. I'm going to try to make students synthesize dye pigments. So they're going to get these vibrant orange and yellow dyes that they're going to make from clear compounds. And they're going to run the reactions to make it happen. I mean, if you're going to do chemistry, do something really cool. Like, either something that's going to like nearly kill you, or really burn you out on something. As much as I hated distilling cumin aldehyde in college, and like, it took a long time before I would eat anything with cumin in it, it was still a positive experience to do steam distillation and go, oh, that's what I'm doing. I'm extracting this oil. I really wish we'd done cinnamaldehyde, because that would have smelled, cinnamon would have smelled a ton better. But if you go back, you'll hear my discussions about the Orgo teacher I had. Kind of makes sense why we did that. That was what Heap's manic decision was that day. Excuse me. All right, so I've enjoyed this discussion, but if we don't have any other chemistry questions, I'm going to go ahead and sign off. I think the homework's due tonight. We are in the home stretch. Next week is going to be the last full... Yeah, I'm going to really advocate we open up that third organic section, because I really think that's where the demand is. I love my Orgo 2 students, but I only have 3 of them. They only need 1 section. So, yeah, next week is the last full lab. Then a week from next Monday is the final exam. We'll get more details as we go into that. Make sure what I'm telling you is actually correct. Yeah, so again, email me, particularly as we start getting towards the ends. If there's any assignments that you haven't done, go ahead and knock them out. With the discussion boards, that's going to kind of count towards your homework. Again, you have all semester to answer those. If you haven't answered them, just go ahead and knock them out. I'll go back and give you the points retroactively. The big thing is you demonstrating and understanding. And as we get, particularly after we pass the exam, we get to next week, we'll start talking about what's involved with the final. And yeah, so I will see you all tomorrow. Thanks for those of you who were able to show up today.